Hello and welcome. My name is Brian McAvoy.
And I'm Tim Schenk. This is episode 10 of Two Cyborgs and a Microphone, brought to you by Twin Cities Plus, creating an intelligent, capable, and resilient community.
This is part one of a 2-episode series on interfaces. Today, we're talking about inputs.
And just to clarify, this is inputs from the perspective of the electronic processor, which is in contrast to inputs to the human senses.
In my job, I've used everything from industrial sensors like ruggedized cameras for barcodes to just using a simple switch made from a couple stripped wires. Any of those are technically inputs. What comes to your mind when I say sensors?
I guess I don't know how to classify them. How would you Let's start with classifying sensors.
It's tough to classify sensors because there are so many. Like I said, even just two stripped wires making a connection is a discrete sensor. It's either on or off. I think a good place to start would be, what are the ones that are useful to us? I think that would be things like our senses. It's easy for us to pick up a sensor that detects just light, photosensitive resistor. It's very easy to read that with a microcontroller, and it's something that we can understand because we have that sense built in. Now, something like an X-ray sensor, we can kind of understand that, but a 5-year-old wouldn't. Telling a 5-year-old, hey, this sensor can detect something that is invisible and leaves absolutely no sensation to you, you'd be like, I don't get it.
Well, I think you could say that is similar to, I think, every other energy sensor, and that it's like light. You can imagine a light when you're talking about, say, electromagnetism. Imagine a light in a certain position and you have a field. So it's, when you're talking about sensors to a kid, you could say it's kind of like a light, except for it's not light. It's a different kind of energy we're sensing, and that's, I think, right in line with the real definition, right?
And that's how we describe them. But the sensors that, as biohackers, that we're going to deal with a lot of the time are things that we can already sense, or things that we wish we could sense. For example, electromagnetic field, that's important to me, but it's something that I can't really sense without an additional sensor.
What would be the next category then? If we're talking about sensors that we've kind of talked about sensors that mimic what we can see or what we actually perceive, and then sensors that we wish we could. What other sensors fall outside of that?
Well, I think that covers everything. We can either sense it already or we can't. But where it starts to get fun is when you sense things in a way you couldn't before. Tim, you'd mentioned one time about the automation you've done to your home. And you brought up an interesting point that really stuck in my mind. I thought it was so cool. You said, what about having distance sensors or motion detectors in every room and having that fed to you as a constant input? You and your house would literally extend one another. You could have a true sense of when somebody's in your house.
Yeah, well, I think that goes beyond any individual sensor. I'm not sure how I would classify that, except for it's an extension of my being. It's something like that. It's an extension of your being.
The end product is greater than the sum of its parts.
Yeah, I agree.
And that's where I think biohacking gets really exciting, because instead of just looking at numbers on a chart and going, yeah, there's somebody in the foyer, you can literally just have a sense of somebody standing there and maybe even know how tall they are or if they're warm or cold or heavy.
Now, that's a lot of information. Because I think that's a great idea. And you say that's my idea in some way. But how would you do something? I mean, how would you... I'm wondering if this is an input or an output question, because we're not doing outputs today. But how would you be able to, on the human side, be able to receive that much input? I mean, sure, presence generally, but how tall somebody is or where they're located, things like that. I would love to be able to do it, but I wonder how you would output that, I guess, to the human body, and that's a subject for a different episode.
your body can only handle so much information at once. And I can think of quite a few ways, in fact, probably a whole show's worth of ways of giving information to your body. It's more a matter of what you are concerned with. If you want to know that a person who walks in your door is heavy, or in other words, compressing a scale below your foyer, hard or soft to know that, oh yeah, my wife is home and she's carrying groceries, I should go help. Or if you want to know somebody walked in through my front door and they're noisy, or what are you interested in reading?
I don't know if I could even define that at this point. I do think it'd be great to have a sense of my home as if it is internal to me. That'd be cool. I'm not sure how real valuable that is, or if it's even possible.
It is, but you'd have to kind of decide what you want to read. To sense every single thing in your house would be overwhelming. Like, do you want to detect if there's a breeze in a room, or do you just want to detect the temperature? These are all the things we can already read with sensors that are actually really inexpensive. A temperature sensor is like $1, or 10 cents if you buy them in bulk.
So I think we need to scale this back a little bit, Brian. We're kind of way out in the clouds at this point. Why don't we talk about it like more of our personal projects?
Yes, let's rein it in, and let's talk about a project that we've both had a hand in, which would be the distance sensors.
The Cyborg distance sensor.
Bingo.
Cyborg distance sensor. I love that. So just for anybody who hasn't heard us talk about it before, I have a magnet, a 3mm by 1mm disc-shaped magnet in the side of my hand. It's implanted underneath the skin. And we have built a prototype, or Brian built a prototype, that I am now developing version 2 of a cuff that I would put on my wrist that vibrates that magnet according to sonar sensor input. So it's ultrasonic waves, just like a bat or a radar, even like radar, where it's sending out a pulse of sound, basically. That is true, right? Ultrasonic is sound, right, Brian?
Yes, ultrasonic and sonar are the same thing. Radar is technically different. It uses radio waves.
Right. So it sends out a pulse of sound and then receives it, and through that, the sensor itself knows the difference in time between when it sent the pulse and when it receives it, and can get a distance measurement. Or it can't get a distance measurement without the right programming behind it, but it knows how long it's been since it's between when it sent the sonic pulse and when it receives it. The end result of this project is I'm going to have a cuff that I can put on. I can put on a blindfold, and I would be able to reach my hand out and feel the objects around me, including doorways and obstacles. So without light, I could navigate my environment, find objects, find doorways, and that's the Cyborg distance sensor. It's exciting.
Yeah, I think it's important that we mention the reason you're doing a cuff is because your magnet is implanted in your wrist. So a bracelet type device makes sense for you. My magnet's in my fingertips, so all I would need to do is route the feedback device to one of my fingers. But the principles, they all are the same between our devices.
Right. And I chose the side of my hand specifically for this purpose, because aside from the fingertips, the next place where there are a high density of sensory neurons is in the side of the hand. And I chose to put my magnet there for this exact purpose. Mm-hmm. Whereas on the finger, a magnet there, it's going to be hard to put something that interacts with it close enough for it to work and not lose the ability to use your fingers for things like picking things up.
Precisely. So I think it's going to be important to say, what do you want to do with this? Where do you want to accomplish? How is this useful?
The first thing for me, it's a proof of concept, because, and you know this as well as anybody, if it works for a sonar sensor, it works for any sensor. So I could swap out the sonar sensor for an infrared sensor, a sound sensor, maybe a radio wave sensor that's sensing Wi-Fi, and it would all behave in generally the same way, where the magnet in my hand would vibrate when that sensor is receiving some threshold of when it's above a certain threshold of input. So the end result of this for me is I'm going to have an array or a number of different cuffs, each one with a different sensor, and the rest of it will all be very similar. If I'm doing home improvements and working on the walls, I will have something that senses electric current, metals, and that senses the pipes, and another that senses electrical current. So I could effectively just wave my hands over the walls and know where the wires and pipes are beneath them.
As an electrician, we already have a device. It's called a hot stick. And what you do is you wave it near an electrical outlet or even insert it in there, and it's isolated, it's insulated so that you don't get zapped. And what it'll do is it'll beep and have usually a light that will indicate that there's electricity there. Now, if you had something like that mounted on your wrist and you were, reaching for a live wire, that would be extremely useful as a safety device, and that really carries well with your idea of having multiple cuffs for doing this sort of thing.
I that's a great idea. I mean, that's right, Brian. What I'm hoping is that maybe through my experimentation, that I can provide the ability for people with a disability like blindness to actually experience their world more fully. Right now, people without vision are really limited to what they can hear plus whatever they can reach with that stick. That's a very limited amount of input from your environment.
Plus, a white cane really sets you apart. It's obvious that you're using it. It takes up a bit of room. It really alerts people to the fact that you need an aid to see.
So the DuoScan, I'm going to pull up a web page here as I'm talking about this because it's pretty exciting. It was MIT that did a study, basically. But what they did is they used gold leaf, which is any of us can get that at any craft store. And they layered it a couple of times, and then they attached it to, I think, USB. But they used a temporary tattoo, common printer paper that's designed to print temporary tattoos, so you can print temporary tattoos at home. And instead of using the printer ink for whatever pattern they're putting on that paper, they just print the pattern and then they cut it out, and then they use gold leaf over it, a few layers of it, and then they put that on the skin. Now they didn't use the same adhesive, so there's a lot of differences here, but essentially they created a temporary tattoo made of metal, gold, that you can touch to send information to your devices. It's an input for devices.
I didn't read it closely enough, but I think what it comes down to is they're capacitive switches mounted on your skin in a very, very low profile way, so that you can, the pictures often show this like slider of chevrons arranged in a pattern, and as you move your finger over it, it gives data to your computer that says, okay, it's at the lowest point, it's moving up the scale.
It's a scroll bar.
Yeah.
So it's essentially a pattern of metal that you place on your skin that when you slide your finger back and forth, it acts as a scroll bar, or a scroll wheel, just as your mouse does. Mm-hmm. And it looks so cool. I mean,
it does look pretty cool.
It looks awesome. And the first thing I said to Sarah when I saw this, because this came up is I did an interview for a magazine for computer science, and he said he wanted to talk about this, and I pulled it up, and I had sent a message to my wife that said that cyborgs are so pretty. Cyborgs are going to be so pretty because if you start putting this stuff all over your body or wherever, it looks so cool. And people are using it for mouse pads, so it can have XYZ or XY. So you can use it as a touchpad on your wrist or wherever you want to put it. There's NFC tags that they put in there. They put on their skin. It's just cool looking. I mean, it's really impressive looking, and that's kind of cool. Mm-hmm. I think that's going to really drive this to the market and to people doing this stuff because it looks beautiful.
Yeah, it's something that the cyborgs need to get into mainstream, is to not be outcast, but to be to be recognized as forward thinkers. Tattoos are cool. I like tattoos. I have tattoos, And these are so much louder. They're metallic. They're right on your skin. They're functional.
And they can even embed things like LEDs. I'm looking at a picture of a necklace that it comes around one side of the neck with wires that then go into this metal print that's on the skin that includes 3 LED lights and then goes up the other side. So it's kind of this necklace with LED lighting made of metal that starts as a 3D object, ends up as a 2D object on the skin, and it's just cool.
It's very cool. I mean, anything from the picture I'm thinking of with the necklace, it looked pretty elegant.
Oh, it's beautiful.
And it would be a very good conversation piece in polite company, or you could wear it to a rave. I don't know if people still go to raves.
Well, I sent something to our mutual friend of ours, Paul, who's a musician. He's into various emerging techs. And I said it'd be really interesting to see somebody make an instrument of their body, because you could use the same concept and make yourself into a MIDI controller. Mm-hmm. So that depending on what part of your body you're touching and where it is, you could be causing sound to happen and make music by touching body. And it could get to be a kind of a you could do some kind of wild stuff, and it could get to a really erotic place, actually. If you had a couple of dancers that were making music as they danced, and it's just cool. And I thought maybe he'd do something with that. We'll see if he does.
The closest I've heard of that was Imogen Heap. She had a MIDI glove. I think it was MIDI, but it would produce sounds based on the way she held her fist. It was an upgraded power glove.
Well, this could just take that to a whole other level.
It would take it to a whole body level.
Yeah. Thank you for listening. We'd like to invite our listeners to email us at 2cyborgs@twincitiesplus.org.
Our constant thanks to Zach Dolan, who created the awesome cover art for our podcast. He's the guy who turned us into cyborgs on paper. I'm the one on the left. This is Brian McAvoy.
And this is Tim Schenk. Please join us for part 2 of our interface series, where we talk about outputs.
With all the do-it-yourself level electronics out there, just about anyone with a garage budget can turn any input into about any output.
You have been listening to 2 Cyborgs and a Microphone, brought to you by Twin Cities Plus, creating an intelligent, capable, and resilient community.
Like, follow, share, +1, and don't forget to subscribe on any of our popular podcast services, including Google Play Music, iTunes, and Stitcher. Help us move up the podcast ladder by subscribing and commenting on iTunes.